Welcome to this video on the topic of programming and fractional arithmetic. In this video, we're going to have a look at two concepts. The first one being we're going to revise the process involved in performing addition and subtraction with fractions. Secondly, we're going to have a look at how we can create a list of instructions that we can use to then create a program or a flowchart that will describe the process of performing arithmetic with fractions. By the end of this video, you should be able to calculate the addition and subtraction of fractions. And secondly, you should be able to recite a set of instructions that can be used for calculating the addition and subtraction of fractions. Now, jumping straight into it, we start off with fractions. We're going to have a look at some terminology, and then subsequently, we're going to have a look at how we can actually compute this problem here. So, what we've got are two fractions. Now, for fractions, they're built in, or they've got two discrete components. They've got a numerator and they've got a denominator. Now, when we look at the numerator is always the information that is held above the line on the fraction. So up here in purple, this is our numerator. Down below, that is our denominator. Now, in this particular example here, what we've got is a fraction on the left, then we've got a fraction on the right. In between that, we've got the operation. In this case, we've got a plus sign. So what this means is that we're going to be performing the operation, that is addition. So we'll call this the operator. Now in the second fraction, we also have a numerator and a denominator. What I'll do is I'll shade those a different color so it will help us with the process when we're adding these two fractions together. Now, if we're going to achieve the addition of 4 over 5 plus 2 over 3, what we're going to start off with is we draw our equal sign like so, and then we're going to get our denominator in our first fraction, so we'll call this denominator 1, and then we're going to get denominator 2, and we're going to multiply these two numbers together. So we'll go 5 times 3. Now that we've got our denominator all sorted out, the next step is I need to draw this line, the line that defines our fraction. Then I'm going to have a look at what is the operator. In this case, we've got the plus operator, so I'm just simply going to put that above the times symbol there. Now, next step, I need to get the first numerator in the fraction, or the first fraction, so 4, and I'm going to write it over here. Then I'm going to get the second numerator, so this 2, and I'll put it over here, like so. Now going back, I'm going to put the times signs behind both of those numbers. Then I'm going to have a look at the second denominator, which is a 3 here, and I'm going to write it 4 times 3. Finally, I'm going to look for the first denominator, which is 5, and I'm going to move it over here. So we get 2 times 5, like so. Alright, now that I've got this pattern all sorted out, it's simply a matter of using BEDMAS to evaluate the arithmetic of all of these numbers. So, in accordance to BEDMAS, when we have the operation of plus, or when we have the operation of plus and times, the times is always going to come first. So what I'm going to do is I'm going to go 4 times 3, and 4 3s there, 12. Then I'm going to put down my plus, because I do plus last, and then I'm going to go 2 times 5, that's 10. Then finally, I'm going to go 5 times 3, and that's 15. Now I'll move down to the final line, and here's where I'm going to do my final answer. We have 12 plus 10 all over 15. First thing I'm going to do is I go 12 plus 10. I know that's 22. I'll draw my fraction line, and then I'll write 15. And thus, we've just completed the process of adding two fractions together. Now, let's have another go with 3 more examples. We have 4 over 5 plus 1 over 3, for example, 1 here. We're going to follow the same process. We're going to get our two denominators, those being 5 and 3, and I'll write it underneath as 5 times 3. And I'm trying to draw my fraction line, and then at the top I grab my first numerator, which is 4. Then I'm going to multiply it with 3. I'm going to put my plus, because we're going for addition. And then we're going to get our second numerator, which is 1, and multiply it with our first denominator, which is 5. Going down the line, I align the equal signs, and then first I'll start with the denominator because that's a nice easy arithmetic. 5 times 3 is 15. Draw my fraction line, and then I go 4 times 3 is 12, plus 1 times 5 is 5. Now I do the addition. 12 plus 5 is 17. Thus, my result is 17 all over 15. Nice and easy. Okay, example 2. We've got 4 over 5 take 1 over 2. Now, we might be thrown by the fact that this is a subtraction. However, it's basically the same as addition. The only difference is rather than adding, we subtract. So, starting off, I'm going to grab the first denominator and second denominator, and I'll multiply them together. So, we'll go 5 times 2. That's going to be all over. Then our operation is minus. So, I'll just put the minus in for now. Then, my first numerator is 4, and my second denominator is 2, so it's 4 times 2. Now, we're going to get our second numerator, and we'll go 1 times, and our first denominator, which is 5. Now we have to deal with the times. So, in the denominator we have 5 times 2, that's 10, and that's all underneath. 4 times 2 is 8. Take 1 times 5 is 5. Therefore, our result is 8 take 5 is 3. So we're going to get 3 over 10. Not bad. Alright, final example. We have 3 over 8 minus 2 over 5. The process which we use is we first get our denominators, 8 and 5, and we multiply them together. Then we draw our line and we look for the operation, which in this case it's subtract, so I'll put a minus in there. Next step, I get the first numerator, which is 3, and I multiply it with the second denominator, which is 5. Finally, we get the second numerator, which is 2, and we multiply it with our first denominator, which is 8. Therefore, 8 times 5 is 40. That's our denominator. And then our numerator, we have to go 3 times 5. That's going to be 15. And then 2 times 8 is going to be 16. So what we have is 15 take 16 all over 40. Now, taking care of the numerator, we have 15 take 16. Well, it's a little bit tricky because we're working with a negative number now. The number we're taking is bigger than the first number. So think about it. What's the difference between 15 and 16? And if we count upwards from 15, we go 15, 16. So it's 1. But because 16 is the bigger number, it's now minus 1. So I'll put minus 1 like so. And then it's all over 40. So what we have here are 3 examples that demonstrate the process involved in adding and subtracting various fractions. Now, let's have a think. Is there a way in which we could describe this using a set of rules that we could then give to a computer to write a program with? And the answer is, sure we can. Let's go up to the top here and let's have a think about it. Our first steps in designing a program are, well, firstly, we need 2 fractions. So we have to get 2 fractions from our user. So we need to say, we'll go for now, we'll just type it in, get two fractions. And then we have to think about what is our operation. So we need to get the operation. And then finally, we need to add, or we need to perform the operation with two fractions. So perform operation with two fractions. Now this is really abstract in that it's not clear enough for a computer to actually follow these sets of instructions. So what we need to do is we need to break this down into smaller steps such that the computer can understand it. So what we'll do is we'll use something called pseudocode to build really discrete instructions such that we can eventually turn it into a flowchart. So starting off, when we say get two fractions, let's think about it. Let's get one fraction, get one fraction, or get a fraction, and then we'll say get a fraction. So we do this twice. We have a fraction here and a fraction here. Now think about it. What's the process of getting a fraction? And the first part is get the numerator and get the denominator, like so. Now, when we get these two numerators and denominators, so the numbers, we need to store them somewhere. So get numerator, store in variable, and we'll call the variable n1, like so. And we'll do the same process for the denominator. So get denominator, store in d1. And what we'll do is we'll promote this. So this little bit here, this is our get fraction. Now we need to do the same for the second fraction. So we'll modify this and we'll say get first fraction. And then copy and paste this and turn it into get second fraction. And we'll change it slightly. Rather than n1 and m2, or n1 and d1, we'll change it to n2 and d2. So first part of our program is get the first fraction, so this guy here. So we get numerator, store in variable n1. Get denominator, store in variable d1. So 4 goes in n1, 5 goes in d1. Next step, get second fraction, get the numerator, store in n2. So 2 goes down into here. And then get denominator, store in variable d2. I'm going to get this 3 and store it into here. Okay, so this is so far so good. We're able to get both of the fractions. Now we need to figure out, are we going to add the two fractions or are we going to subtract the two fractions? So we need to ask the user, we're going to go for plus or minus. So we'll go ask user for operation, and we'll highlight that. So this is a top level step. Then we'll say get operation, like so. And we will store in variable, and we'll call it op, like so. So we're going to ask the user, do we want to add or do we want to subtract? And we're going to store it in this variable op here. Okay, so far so good. We've set up all of the information on the left-hand side of this equal sign here. Now we need to start thinking about how do we do the operations on the right-hand side of the equal sign here. So let's have a think back. We want to be able to perform operation with two fractions. So the process in which we implemented here was, first thing is we get the two denominators and we multiply them together and we write it as the new denominator of our resultant fraction. So what we're going to say is multiply and we'll say D1 with D2. And we're going to store that in variable, and we'll call it D3, like so. So what we're doing with this instruction here is we're getting 5 and 3, and we're multiplying 5 and 3 together and storing it over here. Now next step is, we've got the numerator, so quite a lot's going on here. We've got this 4 times 3, so the first numerator multiplied with the second denominator, plus the second numerator, 2 here, multiplied with the 5, so the first denominator. So what we're going to do is we have to be able to explain that as well. So we'll write, how will we do it? We'll go multiply, and we'll say n1 with, and we're going d2, which should be lowercase, and we're going to store, and we'll call this one in variable, we'll call this one n1d2. So this is the name of our new variable, n1d2. Now, next part is we have to do the same, but for this second part of the numerator here. So the second numerator multiplied with the first denominator. So basically, it's going to be these steps all over again, or these two actually. So we'll go multiply n2 with d1, and that will become n2 d1, like so. Now let's just break this up a little. Okay, and then finally we need to go, we've got the product of 4 and 3 and the product of 2 and 5. We need to add them together. So we need to go add, and we'll go n1d2 with n2d1, like so. And then we're going to store that. Store in, and we'll call it n3. So we've got d3 over here, which is the denominator up here, and then we've got n3, which is now the denominator, which will become this guy here. So we're adding. So in these parts here, we're doing this top operation here, and over here, we're doing this operation here. Okay, so now that we've got the first fraction, got the second fraction, ask the user for the operation, and then we perform the operation. What we need to do is we need to print it to the screen. So output information to user. So what we can say is print, and we want to print n3 and d3, but in the form that's useful. So also print the result is, and then we'll say n3 plus over, and then we'll go d3, like so. And what we've effectively done is we've taken these operations here, so 4 over 5 plus 2 over 3, we've done the denominator and the numerator, we've added the parts of the numerator together, and now we're going to print this result here. So as seen down here, let's get a little bit more space. Okay, so this is all well and good. Let's have a look at it actually running in, say, REPL. So if I go run, then we'll go back and it's saying, I'm a program that adds fractions. Let's add some fractions. Tell me the first fraction. So what we want to put in is 4 over 5. So let's go 4 for our numerator, and 5 is our denominator. Now it says, tell me about the second fraction. We have 2 and 3. So we'll go 2 over 3. And then it's asking, do we want to add or subtract? And we'll go addition, please. And thus, it's going to tell us the result is 22 over 15. When we go back, what we see is the results actually agree with what the program has told us. So what we've got over here is a set of instructions that we can use to build the program that we've just seen running. Now, the program that we just saw, it does addition, but what you noticed is that over here, the program asked us if we wanted to do addition or subtraction. Now, in the code here, the only allocation that it does is for addition. What we need to do is we need to modify it so it can do subtraction as well. So what we need to do is ask the user for the operation. Well, we've done it here, so we need to program it in over here. So what we'll go is if op is addition, or we'll just say plus, then we will do the add, else we will subtract. So what we're doing is we're allowing for the program to do addition and subtraction. Alright, now let's have a look at some test cases. We've got 4 over 5 plus 1 over 3. Let's see if it works. We'll go run 4 over 3, and our second one was 1 over 3, 4 over 5 plus 1 over 3. Let's go back. One over 3, and we're doing addition, and thus we get 17 over 15. Let's compare. So indeed we get 17 over 15. Let's have a look. 4 over 5 minus 1 over 2. Four over 5, 1 over 2, and we're doing subtraction, and thus we get 3 over 10. Let's compare. Indeed we do. Then finally we go 3 over 8 minus 2 over 5. 3 over 8 minus 2 over 5. And we're going subtraction, and we get minus 1 over 40. So, looking back, at the start of this video, we had set out to firstly revise the process of performing addition and subtraction with fractions, and we did that over here. In the second part of the video, what we sought to do was to use the knowledge that we gained in this first part of adding and subtracting fractions to then create a list that we can use to either create a flowchart or a program. And that's what we got over here. So what your task is to do now is have a go at practicing some of this fractional arithmetic and make sure that you know how to do it. If you get stuck, either watch the video again, ask a friend, or ask a teacher. After that, you want to also practice these fractions here. You need to be the absolute master at adding and subtracting fractions. After you've got that down, the next step is get this program here, so this set of instructions, and copy it down into your book. What you'll do is eventually you'll use this set of instructions here to 1. Create a flowchart, and then secondly you'll use it to analyze your flowchart and compare it to the program you saw over here.